on to SPSS. So once the data have been collected, all the data will be put into SPSS. So here first we put in ID, which is unique to every respondent in the study. Next we have gender, which is whether they are female or male. And lastly we have coffee, which is whether they do drink coffee, so meaning it's a yes, and if they don't drink coffee, it's a no. So in this study, there are a total of 440 participants, meaning the N equals to 440. So that is in data view. So as for the variable view, we have the ID and then we have the gender and the coffee, which is the two variables that we are testing in the study. So for gender, it is labeled still as gender, and as for the coffee, it is labeled as coffee drinker. So as for values, for easier computing, so it is computed as 1 is for males and 2 is for females. Whilst for coffee drinker, 1 is for yes, they are a coffee drinker, whilst 2 is no, they are not a coffee drinker. So this way, when the researchers are computing in the data, it's a lot easier for them. So if you press here, so there's only 1 and 2, so it saves them a lot of time from performing or typing down every word by word, females and males. So it's a lot easier for them to just type in 1 and 2, 1 and 2, 1 and 2. Okay. So the way of measurement for both gender and coffee is nominal, meaning that they are a categorical data. So with that, the best way to test the hypothesis in this study is through chi-square analysis, as both gender and coffee is a categorical variable and is a categorical data. So let's look at how to perform the analysis. So first, what we have to do is to check the assumptions. So first assumption is it is done in random sampling. So that is what is done in the study. All of the respondents are sampled randomly. The second is it is independence of observation, and this assumption is met as all of the respondents responds to the questionnaire independently, meaning that their answer do not depend on another person's answer and whatnot. And lastly, the third assumption is to have the expected count of less than 5 in less than 20% of the table. So the way to look at the third assumption is by clicking the chi-square analysis, and then the data or the answer of the assumption will be shown under the table. I'll show you how. So first, we have to click analyze. So right now we are performing the analysis. Next, press descriptive statistics and then go into cross tabs. Next, for the rows, click gender into the row and then click coffee drinker into the column. Next, press statistics and then click chi-square, as that is the test that we are performing right now. Click continue. And for the cells, observe is already clicked, make sure it's clicked, and then expected will also be clicked. And then press continue. And lastly, press OK. And the data will come up in a pop-up. So let's look at it. So based on what we clicked just now, this is the output. So you can see that is the gender times coffee drinker cross tabulation and the chi-square test. But first thing first that we have to check for is the third and a very last assumption that we have not checked yet, which is having a 0 or less than 20% expected count in all of the tables. So where do we check? We check right under the chi-square test. So there's this word saying there is 0 cells that have expected count less than 5. So with that, we can use the chi-square analysis as this last assumption is met. So now all we have to do is refer to the Pearson chi-square's asymptotic significance value, which is 0.596. However, since this data is a 2 times 2 table, meaning that males and females are in the rows, and yes and no is in the column. It's a 2 times 2 table. So for a 2 times 2 table, we have to refer to the continuity correction asymptotic significance value. So this is the Yates correction for continuity, which compensates for the overestimate of the chi-square value when used with a 2 times 2 table. So now we refer to the continuity correction, which is 0.682. So since the p-value of 0.682 is more than significance value, which is 0.05, therefore we fail to reject the null hypothesis. So with that, the chi-square test for independence with Yates continuity correction indicated that there is no significant association between gender and coffee drinking. So with that, we can conclude that it doesn't matter what gender it is, it does not correlate with coffee drinking. So sometimes it could be males that drink more, sometimes it could be females that drink more.